Okay, let's go over the rest of properties of logarithms. Some basic rules. Because you can multiply logarithms, you can also take powers of logarithms. Remember, powers are the exponents. These little guys right there. It's pretty simple. The logarithm of a power is the product of the exponent and the logarithm of the base. So when you have a power, you just drop that in front. So log, which is base 10, 10 raised to the third power is the same as, just drop that 3 in front. This just explains why, but really we're always going to go from here to there, which you see right here. Log base b of a to the p power is the same as p log base b of a. Okay, let's try a few. I have log base 2, 32 raised to the 6th power. It's the same as 6 times log base 2 of 32. And I'm still going to deal with this and say 2 to the what power equals 32. We know 2 raised to the 5th power is 32. So your question mark equals 5, which means you're just going to do 6 times 5 equals 30. Let's try the next one. Okay, I'm going to drop that 20 down in front and have log base 8, 4. Okay, so now we have to figure out 8 to the what power equals 4. This one for me took a little finagling, but if you square 8, you get 64, and the cubed root of 64 is 3, or the cubed root of, 64 is 4. So this is the same as the cubed root of 8 squared. Okay, the cubed root of 64 equals 4. So your question mark equals 2/3. So 20 times 2/3 is 40/3. That is your final answer, just like 30 is your final answer. Okay, try these on your own and then come back and check your answer. Okay, there you go. Bring down the 4. This first one is a natural log, which is base 10. So 10 to the what power equals 10. The question mark is 1, which is why I put it right there. 4 times 1 equals 4. Okay, bring down the 2. Log base 5 of 25. 5 to the what power is 25. Your question mark is 2. You have your answer. Last one. Push pause. There you go. All right, next rule. Exponential and logarithmic operations undo each other since they are inverse operations. So we have basically what we're looking for. When I have a, oh goodness, sorry. Let's erase that. I thought I was on pointer. If I have log b of b raised to the x power, it's x. If these two numbers match, your answer is your exponent. Okay, the same as if I have b raised to the log base b of x, my answer is x. So here I have 10, and my exponent is log base 10 of 2. So my answer is 2. You're going to get used to that. These are just little tricks to make your life easier. All right, let's try these. Using the rules that we just learned, we learned that when these two numbers are the same, my answer is 11. Okay, if you don't remember that, you can still solve it by the rule we learned previous. So drop down that 11 in front, log base 3 of 3, then we deal with just this, 3 to the what power equals 3, your question mark is 1, so your answer is 11, same answer. This next one we can do using the rule we just learned, we just have to figure out what 81 is. So 3 to the 4th power is the same as 81. If these numbers match, your answer is 4. Okay, this next one, the only thing that works really is the rule we just learned. When this number and this number are the same, your answer is very simply 10. Okay, try these on your own. They're pretty simple when you remember the rules. Okay, most calculators calculate logarithms only in base 10 or base e, which we'll get to in a few lessons. You can change a logarithm in one base to a logarithm in another base with the following formula. If I have log base b of x, that can change into log base a of x over log base a of b. And we're always going to make our, when we do these, we're going to make our log our base 10 so that we can actually calculate them. So here's an example. Log base 4 of 8 is the same as log base 2 of 8, log base 2 of 4. They did that because you can do 2 to the what power equals 8. So your question mark is 3 over 2 to the what power equals 4. Your question mark is 2. So that's the answer. And we'll get the same answer when we change it to log base 10. But let's try a few. Log base 32 of 8. We're going to change it into log 8 over log 32. Then I'm going to get out my calculator and do 8 log, I have 0.90309, 32, 1.50515, 0.9 divided by, sorry, I'm doing some calculations here. My answer is 0.6. Pretty simple. Try the next one. I'm always going to do log base 10. Okay. So let me get my calculator going. I get 1.5. Okay, you can try those on your own. Try these next. Oh, I didn't add any more for you guys, sorry. I had 2 examples, so let's move on. But that was pretty simple, and we'll practice when we get to our homework. Logarithmic scales are useful for measuring quantities that have a very wide range of values, such as the intensity or loudness of a sound, or the energy released by an earthquake. We have some earthquake examples here. So the Richter scale is actually logarithmic, which I did not know. So an increase of 1 actually corresponds to a release of 10 times as much energy. It's that exponential function. Things increase exponentially, so each change means it changes even more than just times 2 or times 4. It increases exponentially. The tsunami that devastated parts of Asia in 2004, which was just an amazing tsunami, but it was spawned by an earthquake with a magnitude of 9.3. How many times as much energy did this earthquake release compared to the 6.9 magnitude earthquake that struck San Francisco in 1989? So we're going to use this equation that I've put right here. The Richter magnitude of an earthquake M is related to the energy released in ergs, E, given by the formula. So we know that 9.3 was that earthquake in 2004. It's equal to 2/3 log ergs over 10 to the 11.8 power. Okay, so that's just using the equation. Now let's try to solve for that equation. First thing, I want to get rid of that fraction. I don't like it. You guys don't either. So I'm going to multiply by the reciprocal. To multiply by 3 over 2. Hold on, I have to sneeze. So I have 9.3 times 3 halves. And I get 13.95 equals log of E over 10 to the 11.8 power. Okay, I'm going to move to the next page. Okay, what you actually had there was the division of a log. So log of a division, that actually equals log of E minus log 10 to 11.8. Okay, this log of 10 to 11.8, remember, that's a natural log, so it's actually log base 10. So this simplifies even further. So this problem that looked really scary when you first saw it is actually getting so much easier. Okay, I'm going to add 11.8 to both sides. And I'm left with 25.75 equals log E. Okay, that means, this is a base 10 again, 10 to the 25.75 equals E. See how I just changed it from logarithmic to exponential? That was early on in our lessons. If we actually do that math, that means E equals 5.6 times 10 to the 25th. Okay, this was the magnitude of the tsunami. And that is in ergs. Bet you never knew what an erg was. Let's look at the other one. I have magnitude equals 2/3 log E over 10 to 11.8. Okay, our magnitude for this one was 6.9. 10 to the, 11.8. I'm going to multiply that by 3/2 again. Didn't leave much room over there. Okay, those cancel out. And I'm left with, do that multiplication real quick, 10.35 log base E over 10 to the 11.8. Again, division gives us log E minus log 10 to the 11.8. Simplifies further, minus 11.8. Add 11.8 to both sides, and I'm left with 22.15 equals log E. Now that's a natural log, so that's logarithmic form. We can change it to exponential, and we get 10 to the 22.15 equals E. So E equals, let's see what we have here. Crunch a number, 1.4 times 10 to the 22 ergs. Now go back to the beginning. This was the 1989 earthquake. It actually asks us the difference in magnitude. All right, this actually asks how many times more was the tsunami in 2004 than the one in 1989. So we're just going to do some basic division. This was the 2004 tsunami and the 1989 tsunami. Do that division and we get 4,000 times as much energy. And there was a lot of destruction for both of them, actually. Okay, why don't you guys try this one? How many times as much energy is released by an earthquake with magnitude 9.2 than an earthquake with magnitude 8? I'm going to push pause. You guys can crunch all the numbers and give us the final answer. Okay, the energy released by the 9.2 earthquake was 4.0 times 10 to the 25th. Let's do the next one. All right, the 8.0 magnitude earthquake gives us an energy release of 6.3 times 10 to the 23rd. Go ahead and look through the work, and the next slide we're going to do that division. Compare the energies. So the 9-point-some earthquake gave us an energy of 4.0 times 10 to the 25th. Over the one we just finished, times 10 to the 23rd, 63 times greater. Our answer. That's all we got for today.